All right. All right, so let's jump into 3.2. And I think again, so you've already read over that section and worked the what do you call it? The reading assignment. I think hopefully what you saw from that section is we're literally just now, in 3.1, we introduced the idea of using for all and there exists into these statements, and we call them predicate statements. They're what's the root word for that? Yeah, but anyways, so you'll see in this section, all they did is they added in all the if-then statements, and I think what do you call it? Did we do negations? No, I think we're doing negations too in this section. So those same elements that, not just same elements, but really the same flow that we did for the last chapter, you're going to see here. We're going to negate some of these statements, and then we're going to throw in some if-then statements and make contrapositive, um, converse, inverse, etc. You'll see, I really want to focus on working on the converse, inverse, and contrapositive, because so far the homework that I've been grading out of chapter 2 for y'all, that's where actually most of the mistakes are. Most of your mistakes, there isn't a lot of mistakes. So overall, people are doing well on the homework. Just, very few mistakes for most people. But if you are making mistakes, that's actually where it tends to be, is a little bit with it's just with contrapositives, converse, and inverse. So when we get to those problems, you'll see I really want to spend some time on those problems. All right. So let's start with the. Let me get in on my side, but let's start with the reading questions. First question, number 1 there. Which of the following is a negation for all discrete mathematics students are athletic? More than one answer may be correct. So notice the statement that's given to you is this sort of informal version, and these options are your informal version. So there you're also going to see in this section more of that informal versus formal. But for this question, really the focus is how do we negate these for all and there exist statements. And so when you have a for all statement, I'm saying it's true for everything in every case, for whatever our objects are. But it works for every single one of them. And we were talking about in the last section how, so if you have a for all this statement and you want to show that it's false, all you have to do is show that it doesn't work for one of them. So whatever the domain is, the set of objects this is supposed to work for, that for all applies to, you just got to show it doesn't work for one of them, right? So think about that in terms of truth values. If we have a statement, sort of, it's either we're assuming it's true or the person is saying it's true to you, and you show it's false by showing one example where it doesn't work. So then think about, and what we talked about in the last section, that one example not working, or one example working, that's a there exists statement. So there exists statement means there's at least one that satisfies the condition. For all means everything. So then it actually seems natural then the negation of for all should be there exists, because in that sense, they have opposite truth values. And vice versa, the negation of a there exists should be a for all. So that's all you really need to know for that's the main thing you need to know, or sorry, the main new thing they're teaching you about negations in this section. So that's really the idea you need to just have pinned down in your head. Negation of for all is there exists, and negation of there exists is for all. They just switch back and forth. So we end up, again, we're sort of getting these binary conditions on statements and kind of throughout the course. Wait a second, there was something else. There was something else I was thinking about there, but let's get to the question. So the statement was all discrete mathematics students are athletic, which I was a discrete mathematics student and I'm not athletic, so boom. Counterexample, not true, right? So the negation of that. And so let's look at A. Says there is a discrete mathematics student who is non-athletic. So this is true. This is one possible negation. So one would have been possibly A. Because again, what I'm saying is there's at least one that's non-athletic. That's all I got to do to negate that statement or show the opposite. B says all discrete mathematics students are non-athletic. So is it the interesting distinction between A and B? So again, the negation of a for all is that there exists. So if to prove somebody says something, all of them work, then your negation to that, your opposite to that is to say, no, it doesn't work here. And there may be other places where it doesn't work. There may be other examples, but you just got to show one. However, what isn't true or isn't the opposite or negation of a for all is another for all or like sort of the negated statement. So B is saying all discrete mathematics students are non-athletic. That is not a negation of the original statement because we're not going all the way. We're not when we say all discrete mathematics students are athletic and we want to negate that, we're not going to go all the way to the other side and say they're all not non-athletic. Again, then that's actually not even in the same zone. That's a for all statement, just for a different condition, for the opposite condition. So again, the negation of a for all is that there exists. So I just want things that say there exists. There is one. There can be only one. So B doesn't work. C says there's an athletic person who's not a discrete mathematics student. So notice that that's not even, I mean, that's like things, the two statements are switched around and there's some negations. Yeah, there's negations of statements which we need, but we kind of switch the statements around. So that definitely doesn't work. Let's see. No discrete mathematics students are athletic. So again, this is kind of like B. D is like B. It says not the negation of our statement, but it says sort of the full opposite, I guess is one way to think about it. Yeah, again, a negation is not necessarily a full opposite. It's just logically, the true to the false and the false to the true. Anyway, so D doesn't work. Some discrete mathematics students are non-athletic. That would work. So A, E, and no athletic people are discrete mathematics students. Again, that's flipping the order of really, another way to think about it is flipping the order of your objects here. So my original statement says all discrete mathematics students are athletic. So I'm highlighting discrete mathematics students and saying they're all athletic. Something like F and I think it's C is flipping it around and saying these are athletic people or non-athletic people, and then here's their condition with discrete mathematics. Again, that's flipping it around. Remember from chapter 2 that really any of these statements we can rewrite as an if-then statement. So you can even think about the original statement. The original statement says all discrete mathematics students are athletic. The if-then version of that would be something like if a student is a discrete math major, then they are athletic. So again, if you look at F and C, they're the converse. It's literally they're the converse. They're switching things around. Anyways, so the only two that actually work here are A and E. Oh wait, hold on. Let me scroll down. Oh yeah, there wasn't a G. All right. Just want to. So I had you do 3A and 4A also to same thing. You wanted to do a negation, but here I wanted you to write it formally. So 3A says for all strings S has at least one character. So talking about strings and programming. So my claim is for all strings that you could write S, S has at least one character. It has to have one character in it. And if you're going to write a negation of that, your negation of this should have been then there exists a string S such that S, and we need the negation of at least one character. The negation of that would be no characters. That has no characters. S may be a character, but it has no character. No, but a string with no characters. For A, you are back to writing, in this case, you want an informal negation for each of the following statements. Um, I can't do this because could do. What did I give you? Okay, let me see if maybe we'll do another. Um, yeah, so before we do 4A, let's at least do, so I'm gonna have you guys do 3C, so that wasn't part of your reading. But again, you kind of, both from your reading and hopefully a little bit from my explanation there, you get the idea. You know, negation of 4-alls there exists, and vice versa. Negation of there exists is a 4-all. So let's do it there exists. So I'll give you guys a second to go ahead and write the negation of 3C there. I'll pause, you pause. All right, so let's take a look at what you're getting for C there. So C says there exists a movie M such that M is over 6 hours long, and we needed to negate that. That should have given you a 4-all. So we might say something like this: for all movies M. And then what was the negation of it being over 6 hours long? Good, it would have to be 6 hours or less. So M is, and you could say this several ways, but I'm going to say less than or equal to 6 hours. So something like that. Honestly, the way that you say this, it's just got to communicate this less than or equal to 6 hours, but there's several different ways, you know, informally you can say that. So let's look at 4A. We'll do something similar. Look at 4A, and I'll give you all one to do. 4A, I wanted an informal negation. So just on 4A, we're still doing the same thing. We're writing negations. They just, I guess like the original, like number 1 there, they give us the statement as an informally, and so they want the negation informally. So part A, the statement was all dogs are friendly. So what did you get as the negation for that? Good. So we're saying all of them are friendly. So you might say, again, if you're trying to counter that or say that that's false, you might say, well, there is this one, you know, Cujo or whatever, the Rottweiler in the neighborhood that's, you know, outside and not well trained. But anyways, there is one, right? So that's all we really got to say is we've got to say informally, there is one dog that isn't friendly. So all dogs are friendly. Negation is there is an unfriendly dog. Again, you could be a little more wordy about this. I'm trying to just, you know, these statements are pretty short, so in some ways I'm trying to give them back what they gave to me. Get back. But give them back what they gave to me. They gave me a short statement, kind of like not concise is not the right word, but it's kind of clever and it's short, it's shortness and simplicity. So I'm trying to give them something similar back. There is an unfriendly dog. That's probably as short as you can make it. That's all you really need to say. So for C, we'll just do this as a class. But for C says some suspicions were substantiated. But this is a there exists statement, a some statement. Some gets used a lot informally for there exists or there's at least one, right? So some suspicions were substantiated. What would be the negation of that? So maybe something like, so again, it's going to be an all statement. So all suspicions were, and what's the opposite of substantiated? Unsubstantiated. All suspicions were unsubstantiated. Had no merit or ground in real life or the observations yeah, just what they picked up from the scene of the crime, all that kind of good stuff. So all suspicions were unsubstantiated. That was all I gave you for the reading. So in some sense, what I wanted to do with the reading was just float you into, the first thing he talked about in this, she talked about in this section, which is negations. Now let's work our way through some of the other ideas in this section. Or, yeah, just can't do that. You guys kind of get the idea. I think that I don't need to do another one. Well, I think that's actually, I mean, yeah, we don't. You'll just see some more problems where you gotta write negations. Let's jump down to. Those are all jump down to maybe our last negation, our last couple negations of just a regular statement. So I'm in the 16, 17, 18, 19, 16 through 23 area of the exercises. And in these exercises, they want you to write a negation for each statement. So we're just gonna write a negation. These are gonna be, I mean, they're really more informal, but they're a decent mix they're really more formal, but they're a decent mix of informal because some of these things can only be written really with words. Mostly with words. So I think what I want y'all to do. Yeah, since we've got sort of some practice writing negations. Let's see which ones is it. Planned this yesterday, but I forgot my plan. Do a little mimic. So I think what I'm gonna have you guys do then, I think the ones that I want to look at out of this section is number 16. You guys work on writing the negations in 16. Something else. A little too. Well, so we're gonna do 16. We'll do 21. And I think need something like maybe 22 as well. So I want you to write the negation on all three of those. Some of those statements are more formal, some of them are more informal, but again, we just kind of practice that with a couple problems, so you guys should be able to run through that really well. So let me give you kind of the appropriate time to do this. So I'll pause on my side, you pause on your side, and let's see what we get for these negations. All right, let's see what y'all are getting here. So on 16. For all real numbers x, if x squared is greater than 1, then x is greater than 0. And so we wanted to negate that. First of all, it's a for all statement, so our negation is going to be a there exists. So there exists real number x such that, and then we have to deal with the negation of the if then. So part of the reason, honestly, that I really wanted to make sure we went through these questions is this whole business of negating an if then. Most of the homeworks from last week, you guys were good, but there were still a couple of people struggling with negating an if then statement. Remember, when you negate an if then statement, it's not just negating each part of the if then statement. So several people confuse negation with, that would actually be the inverse of the if then statement. So you can't just negate each part. You actually have to do something kind of not wholly different, but I mean, you have to do something different there. So when we negate an if then statement, how do we do that? Or what do we get? What's the pattern? Good. And for an if then statement, so for P implies Q, the negation of that is P and not Q. So the negation of an if then statement is an and statement. So again, a couple things. It's definitely not an if then statement. So if you negate an if then statement, the whole statement, and you write if then you don't have a negation. And then what we do need is an and statement, but we need an and statement where the first part, the hypothesis, stays. There's no negation there. But the second part, the conclusion, we do negate. So then the other kind of weird thing about it is, again, it's not an if then statement, and you don't negate each part. You actually just negate the second part. So on 16, this should have been there exists a real number x, such that x squared is greater than or equal to 1, so we're not negating that at all. But, or you could say and, hold on, it's off on the screen, but you could say but, or you could say and, but we need the negation of x is greater than 0, and that would have been x is less than or equal to 0. Oh, I'm sorry. I was looking at the wrong one when I looked at that, sorry. The original statement says x is correct. Now I'm getting it wrong. X is greater than or equal to 0. No, that's correct. Good. Good. So that would be the negation there on 16. Good. 21. 21 said for all integers n, if n is divisible by 6, then n is divisible by 2, and is divisible by 3. You might note, you might recognize that that was one of your homework problems that you worked through out of chapter 2. I guess it would have been section 2. But yeah. So they literally just took that statement and essentially turned it into a for all statement. So the negation of this would be there exists an integer n. So one thing really quick, this comma technically means such that, but for me, whenever I read it, I just never read it that way. It's really hard for me to read it that way, and it just never sticks out like that. It sticks out whenever I read it, I still read it like a comma in written language, where it's just sort of a pause between two phrases. So I will tend to write the such that. You don't have to, but I'll tend to write the such that there, just because it, I want it to read complete in my head at least. So there exists an integer n such that, and again, we want the negation of this, which you guys did well with, by the way, in your homework. So the negation of this would be n is divisible by 6, so we keep the hypothesis by 6, but then we needed to negate the back end of that statement. And in negating that, so first of all, I mean, we're just saying things are not divisible by 2 or not divisible by 3, but the more important thing there is there's an and. That back part of the statement is an and statement, and the negation of an and statement is an or statement. So this should read, there exists an integer n such that n is divisible by 6, but either so yeah, let's talk about a bit of wording here. N is divisible by 2, or n is, man, I'm writing horribly right now, divisible by 3. That would be one of the ways to write this out. I do want to talk about some wording here. So the other small mistake. So in the negations, like I said, you guys did well with the negations. The only mistakes I saw, and this didn't happen often, but actually was in the using of this phrase either or. So I want to we'll rework, or we'll just kind of talk through this answer the way it is and rework that phrase a little bit and see kind of what works and what doesn't. So I said that the negation of an and is an or statement. So you want to make sure that this back end is an or statement. So there's a couple ways to make that an or statement. You can do it like I did here, either or we honestly don't need the word either here. We could just say, but n is divisible by 2 or n is divisible by 3. Honestly, the word either from, again, a written language standpoint or a communicating language standpoint is a bit redundant, or does the same thing. It tells you the same idea. So you really don't need the either. So you can write it this way, or you can leave out the either. One of the things that I saw trip people up is this word either, because what I saw happen for several people is they went ahead and stuck an n there and an n there, made it neither nor. Problem with neither nor is that is actually an and statement, because you're saying it's not You basically, we use neither when we negate things sometimes, but you're saying it's not this thing and it's not this thing. So I think what I saw happen for just a couple people was you probably knew that it was either or in your head, but you went to neither nor, and neither nor is an and statement. Again, notice too that neither is trying to say not. Oh, I forgot to write the words not here. I'm sorry, guys. Well, no, yeah. No, actually, this works the way it is. Neither is trying to say the word not. Um, I'm really sorry, guys. Tired right now, so I missed something in the original writing of this. But neither is trying to say the word not, and we already have not in our statements. So again, that neither actually becomes redundant, at least in this case. What I didn't do though when I originally wrote it is I think I said the word not, I think, but I didn't write the word not. So can't use neither nor. And like I said, both neither and either are actually redundant here, so you really don't need them at all. I'll keep it there just because that's how I originally wrote it. This should say, I'm sorry, such that n is divisible by 6, but either n is not divisible by 2. These should have nots here. Or n is not divisible by 3. Just missed that when I was writing. That should be either n is not divisible by 2 or n is not divisible by 3. Very good. And then let's also do 22 really quick. So 22, this is an informal statement. If the square of an integer is odd, then the integer is odd. So what we're trying to say here is for any odd integer I can think of, or no, sorry, for any squared integer, or any result of squaring, if it's odd, then the number that you squared is odd. So it's kind of in some sense looking at squaring backwards, or you can think of it like a square root. So when you have some number that's the result of something over here squared, and they're saying if this is odd, then this is odd. But they're saying that, it says if the square of an integer is odd, then the integer is odd. That implies that works every time. That's what they're trying to say. Every time the result over here is odd from squaring, the seed that we started with, the number that we squared is odd. So it's a for all statement. So the first thing about this honestly was just reading it and realizing it's a for all statement. So then the negation of it, or the way I would prove, the counterexample, the way I prove it's false is, and we want to write this informally since they gave it to us informally. So the way we'd say this is there is an integer. Yeah, there is an integer such that square of the integer is odd, but the integer itself is not odd, or you could say even. So the negation of this would be there. There is an integer n. Where n squared is odd, I actually would write it this way. Even though I'm doing something informal, I personally occasionally throw in expressions and equations because they just make sense out of things. I mean, they explain it well and concisely. So there is an integer n where n squared is odd, but n is even. So those would all be the negations there. Again, notice they're all, in this case, there exist statements because we start with for all statements. and none of them are if-then statements. So like I said, the one confusion that I saw that was maybe more than just a couple people was this confusion between negation and then the other statements we're about to talk about, which is contrapositive, converse, and inverse. All of those statements are if-then statements, so they cannot be a negation. So let's go to, we're gonna look at the next batch of exercises. This is actually the exercises are set up similar to how they set up the exercises in 2.2. You'll notice that they're gonna give you the same statements, the same for all statements we just looked at. And in 27 through 33, they're saying for each statement reference, for each statement, write the contrapositive, converse, and inverse. So we're just gonna go ahead and write all three for each one of them. So for instance, if you look at 26, 26 is the same statement as 16, and now you gotta go through and write converse, inverse, and contrapositive. So what I wanna do really quick is, again, let's do a little compare and contrast so you don't get these confused. So 26, based off the same statement. So now instead of the negation, I want to write converse, inverse, and contrapositive. So here, I want you guys to remember that, so again, if we, let's see. Yeah, it's right over here. So if we have an if-then statement, P implies Q. So how do we form the converse of that statement? What's kind of our pattern? Good. And you don't have to say it in fancy words either. So if you kind of are sitting there like, I don't remember how to say it or what was said, I promise you that you remember the idea, you remember the pattern, and that's really it. Ideas and patterns, like those are truth. The words that we put on it, I mean, that's just you kind of checking like that what you're saying, like maybe makes sense to another person or communicates well or whatever. But if you don't remember that, you still know what's true. You just got to find a way to communicate it. So I'm saying all that to say, like when we talk about doing the converse here, I'm going to write it formally. But I want you to catch the pattern and the idea. The pattern idea is the truth. And you can use that pattern idea going forward. You don't really have to memorize this little symbology. But if memorizing symbology helps you see the pattern, definitely do that. Sorry. So converse. All we're doing with the converse is we're switching the hypothesis and conclusion, and notice that it's still an if-then statement. So, actually, yeah, let me do it this way. Let me do it slightly less symbolically. So if P then Q is our original statement. So again, with the converse, all you do is you switch these two around. The two statements, P and Q. So this is going to say if Q, then P. So just switching P and Q. And so that's what you'll see with our statement with 26. It's not going to look like 16. You want to go back to the original statement. It's going to look like that for all statement, but you're going to switch your if and your then. Well, let me have you guys write that really quick, actually. So we'll just take a second. I'll pause really quick. You pause really quick. Go ahead and write the converse of the statement in 26. All right. So then, based off our original statement, my converse is gonna be for all real numbers x. If, I don't know what that was. X is greater than 0. Then x squared is greater than or equal to greater than or equal to, what did I say? 1. Okay. Good. And that would be the converse. So again, notice all I did is I just literally switched these two phrases. So let's do this with sorry, we're not there yet. Sorry, converse. Okay, so then the next thing is the inverse. Honestly, I think I probably saw, again, there wasn't a ton of mistakes, but the more consistent mistakes were usually on the inverse, actually. And for inverse, again, if I'm starting with if P then Q, inverse means just to negate both parts, but you keep the if then. So this is gonna be if not Q, then not P. So you are not gonna sorry. Moving ahead in my mind, I got it backwards. So if not P, then not Q. So notice that you're not switching P and Q, you're just negating both parts. So in the converse, you switch them, in the inverse, you don't, you just negate them. Right, same deal then. Go ahead and pause for a second. I'll pause and work on that. All right, sweet. So for this one, again, it's still for all. So again, in none of this, it is only in the negation that you actually change the for all. So, and this is still for all real numbers x. So really like so the idea is, again, for any of these switches, so I'll call them kind of switches of your if then, your original if then statement, none of them change the fact that we're claiming this for all, again, numbers, nouns, whatever that fit the category. We're just changing the conditions that we're claiming essentially, which is so here it would be for all real numbers x. And we want to take, again, the original, and you just want to negate each part. So negating each part there then should be, so x squared greater than or equal to 1. The negation of that is x squared is less than 1. So if x squared is less than 1, then x is, I think it was originally greater than 0, so it should be less than or equal to 0. That would be the negation there. Less than 1, less than or equal to 0. Yes, that's all correct. Good. All right, and then finally we have the contrapositive. So again, converse was what I call it was flipping the order. Inverse was just negating each piece. So then contrapositive is doing both. You're gonna switch, I guess I was calling it a switch. You're gonna switch and negate both parts. So you can honestly almost see it just again from these two. You could like literally write it from these two that so like contrapositive for all real numbers. All real numbers x. And so we know that we both switch and negate. So you're gonna switch like you did for the converse, but then in each of these parts, you're gonna go ahead and negate it like you did in the inverse. So if x is less than or equal to 0, then x squared is less than 1. Good. That would be your converse, inverse, and contrapositive. So sorry, symbolically, the way we usually say the contrapositive, so we'd say if not Q, then not P. So again, being able to negate and then separate that from your converse, inverse, and contrapositive is really important skill, but just really important point to kind of sort out in your head. So like I said, it's not that you guys did great on the homework last week. But if there was any consistent confusions, that doesn't mean majority, I'm just saying consistent confusions. It was a lot of y'all wrote the negation instead of writing the when you did negation, you wrote the inverse instead of that, or from those mistakes. I saw people write for negation, they did inverse. Saw a couple, like one or two people do the contrapositive for the negation. So you just want to sort of separate those out in your head. All right, let's see. I don't think I want to do, we did 3 negations. I don't think I want to do all 3 of them for this part, the converse, inverse, contrapositive. It's enough to probably just do another one of these. So let's see. Mm. Mm. I think just because of how long that one will take, I'll do, instead we'll do probably 32. So 32 again mimics our previous statement we did the negation of. This time though, I want you to not do a negation. I want you to do converse, inverse, and contrapositive. Yeah. If you have a chance, take a look at 31. I want to do that, but just for the sake of time that it would take to write it out, I can't really dive into that. So let's do 32. So I'll pause, you pause. Go ahead and write your converse, inverse, and contrapositive on 32. All right, good. So for 32 then. So the original statement, if the square of an integer is odd, then the integer is odd. So the converse. So here the for all is implied, so I don't have to write all of that. I just have to rewrite it, with those phrases informally. For the converse, all we're doing is switching, flipping the P and the Q. So this one should say Oh, this is really just a repeat of the last section then. If an integer is odd, then you can say the square of that integer. You can say what I'm about to do just to make this shorter. Then you can say then its square is odd. The inverse, I'm going to go back to the original setup and I'm just going to negate each part, or the statements, the if statement and the then statement. So if the square of an integer even. So you don't know sort of the definitions for even and odd yet, but we kind of know what it means and what it is. And so you can definitely kind of check in your head every one of any numbers, at least any integer is either even or odd. But the square of an integer is even, then the integer must be even. Where is it? Hmm. And the contrapositive, I wanted to switch it like the converse and then negate. Basically take the converse and negate both parts. So the contrapositive. If an integer is even, then its square is even. And that would be your converse, inverse, and contrapositive there. All right, so let me check. There wasn't much more, I think, that out of this section that we wanted anyways. Let me look at. Yeah, actually. So the only thing else that I want to look at in this section is, again, just like 2.2. 2.2, we talked about sufficient and necessary. They kind of come back and just remind you about it, but now using for all and there exists. So I think we're gonna do 40, I think it's 45 and 47. What I plan to do for y'all. 45 says being divisible by 8 is not a necessary condition for being divisible by 4. And here what they want you to do is they want you to actually write a negation of this statement without using the word necessary or sufficient. So in 2.2, I think what we did is we saw necessary, we saw what do you call it? Sufficient. And in some of the problems you did, you end up well, no, you didn't negate them. So the idea here is we know what they should look like as an if-then statement, and then we want to negate that. That's interesting. Yeah, so they want you to negate it. So being divisible by 8 is not a necessary condition for being divisible by 4. So the first thing we want to do here is kind of sketch out the first thing you want to do is sketch out what it looks like as an if-then statement, and then you want to negate it. So both of those things, though, are things you can do. Give me a second to think that, I mean, we could pause and go after this, but I think I just want to go through these. Hold on, give me a second. All right. Take a slight nap there. Not really, but I probably should have. So for 45 here, being divisible by 8 is not a necessary condition for being divisible by 4. So I do just kind of want to, let's run through these as a class, but just relying on, again, what do you know from 2.2. So first of all, let's treat it as if the word not is not in there. So without not, we're saying being divisible by 8 is necessary for being divisible by 4. So the first thing then is, how do you translate that as an if-then statement? Good, and as an if-then statement, so necessary, when we have that necessary, that means it's basically, one way to translate that is if Q, then P. So again, we kind of have these. P implies Q if there's a necessary there. Well, actually, no, this isn't the best way to write it, but okay, we'll just keep it verbal. Keep it oral, keep it audio. But being divisible by 8 is necessary for being divisible by 4 means that if it's divisible by 4, it's divisible by, so it means if Q, then P. That's the idea you want to take away there. So if the end, then the beginning. So this isn't the final answer on this. This is just the if then that we're going to need here. So if we're going to say if an integer. Oh my goodness, I'm writing so. If an integer is divisible by 4. Then it's divisible by 8. So then what we're going to do is write the negation. So that's the idea of these problems. Again, the way it's said, it's a necessary sufficient, but the difference between this and 2.2 is that there's a not in there. So you can you can write it out, or you can just, say it with your voice, patch it, or, just see it in your head. But either way, you're going to need this, because then we need to negate that. The not implies you're going to negate that whole thing. And the negation of this, so again, when you negate an if-then statement, it is no longer an if-then. And you are going to keep the initial statement and negate the second statement and turn it into an and statement. So the negation of this is also, this is a for all statement, sort of, it's implied that it's for all. So the negation of this is going to sound like a there exists statement. So negation is there is an integer that is divisible by 4. Again, I'm going to keep that hypothesis. Every time I word the word divisible, there's a couple words like this. It like scares me how many eyes there are in there. It's just weird. So there is an integer that is divisible by 4, and in this case, we're gonna say but because we're sort of making a not claim, but not divisible by 8. So I'm gonna take at end, the conclusion, and I'm gonna write the negation of it, but not divisible by 8. And that would be the negation, that would be this, so what, kind of what we're doing though is that would be 45 written out. Informally as an if-then statement. Anyways, that's just what they want out of this, they want you to rewrite the statement, so there is an integer that is divisible by 4, but not divisible by 8. On 47, so 47 says having a large income is not a sufficient condition for a person to be happy. So necessary meant if Q then P, if the end of the original statement then the beginning. Sufficient means if the beginning then the end, if P then Q. So here again, we have having a large income is not a sufficient condition for a person to be happy. So the first thing you need to do, sort of again, either in your head or on paper, is think through the if then statement. The if then statement here is going to be if you have a large income, then you're happy. If if you have a large income, then you're happy. Sort of an implied you in this sentence, the original sentence. But again, the original sentence is saying basically it's not the case. So the original says having large income is not a sufficient condition for a person to be happy. So this is the sufficient condition, and we want to write the negation of that. So I'll give you guys, I won't even pause it, but I'll give you guys a second then to write the negation of that statement there. Let's see what you're getting for the negation. So the negation of this, again, you're going to keep the if, it's going to be and the negating the end. The negation of this is there is a person. So again, this is originally a for all statement. So we're saying, well, again, like I've kind of talked about when we did 2.2. So, or I think it was 2.1, whichever one it was. But so again, let's say somebody comes to you and says, if you have a large income, then you're happy. And you're just like, in your head, you're like, well, that's crazy. I know plenty of people, right, that have a large income and aren't happy. So again, for you to refute that, to debate it, to negate it, you have to show them an example. You have to give them an example of a person who indeed has a large income, but they're not happy. And that's exactly what the negation of this statement is. There is a person who has a large income but is not happy. And that would be that statement rewritten, not using the word sufficient. So this is the negation. That's kind of where we were going. So that's correct. That's our answer. And so is this. All right. And that's everything for this section. So again, touching on the same stuff from basically 2.2, just now with for all and there exists. All right, so that'll get you guys going on that homework. Go ahead and run that through, and then I will see you guys. So we'll look at 3.3 next. We're gonna look at 3.3 next, and then that's actually it for everything before this first test. So I'll be sending out a message, hopefully tonight, but maybe not tonight, but at least tomorrow. I'll be sending out a message to you guys, just kind of giving details about the test next week, so you can start getting yourself ready and set up for that. So I will send that out either hopefully tonight or tomorrow. And I also wanted to have the video for 3.3 up tonight. So when I say tonight, I'm saying Tuesday night. But if I don't get to that, then I'll definitely have it up. It should have it up Thursday. So, but yeah, so I'll see you guys for 3.3. We'll again just kind of actually, now that we have the for all and there exists, we're just gonna take that a little farther in 3.3. All right, see you guys there.